Greetings, math person, and don't be afraid to learn from your mistakes. Kudos to your teacher for assigning this because there are so many different ways to answer, and giving a problem like that really deepens your understanding of the concept. So the first thing we're going to do is look at this rational expression, and we're supposed to find other rational expressions that would be equivalent. So one easy way to do it is to just look at this fraction of 3/4 and find other fractions that are the same. So 9/12 is just another version of 3/4. And we've got the YZ on top just as there. So those are equivalent. And 30/40 is another version of 3/4, although this time we added 1 power of y and z on the top and 1 power of y and z on the bottom. But if we put those powers on the top and the bottom, we really only added a factor of 1. And when you multiply by 1, you get the same thing. Likewise, down here, we have 15/20, which is another version of 3/4. And we have an x over an x, which if we divide those, x divided by x, that's 1. So we can cross those out without changing anything. And again, we have more power of y on the top than the bottom, and 1 more power of z on the top than the bottom. And that results in just y and z remaining on the top. Now, over here, we have a binomial of x plus 2 being multiplied times 3 and by yz. And likewise on the bottom, a binomial of x plus 2 multiplied by 4. And because they're multiplied, we can cross this out because x plus 2 divided by x plus 2 is just 1. And so after crossing those out, it looks just like that. Now, on this next screen, I believe your teacher wanted us to find rational expressions that are equal to 0. And for a rational expression to be equal to 0, you just need to have a 0 on the top, or the numerator needs to be equal to 0. The denominator doesn't matter, except that it should not also be 0. 0 divided by 0 is undefined. So as long as this isn't 0, we're going to be fine. As long as x isn't -1/2, then this denominator won't be 0. On this one, we have 0 times a binomial, and 0 times anything is still 0. So our numerator is 0 like we wanted, and we just have to make sure that we don't also have a denominator of 0, and we can do that by making sure that x doesn't take on the value 0 or -1/3. So either one of those would make the denominator 0. On this one, we don't have to worry about the value of x because we don't have any x's in the denominator. So no matter what we do on the top, we're going to be dividing by 37, and that's okay. We can divide by any number except 0. And on the top, we have 0 times something, and 0 times anything is 0. All right, on this last one, we are looking at a binomial divided by a binomial. And this is fine as long as we're not dividing by 0. So x can't be -3 because that would be -3 plus 3 on the bottom. On this one, we could simplify this into that by getting rid of x plus 2 over x plus 2. So x plus 2 divided by x plus 2 is 1. That's why we're able to do that. And this, we have to make sure that x is not -2 or -3 so that we don't get a 0 out of the denominator. These two at the bottom are really two different versions of the same thing. This is the trinomial over a trinomial version, and this is the product of two binomials over the product of two binomials version. You can see how we can cross these out on that one because we have x plus 5 over x plus 5. And you can see that on this version, the same thing could happen if we change these into the factored version. So we can't really cross anything out here. We still do have to make sure that x is not -5 or -3, because that would make the denominator 0. But writing this version allows us to see why this version is still going to work. Okay. So thanks for watching. Remember, you are a math person, and don't be afraid to learn from your mistakes.